Okay, so let's talk about the difference between atoms and ions. Now, before we can even get into atoms and ions, we have to understand what charge is and how something can become charged or not have a charge and be neutral. So let's talk about charge first. Now, if you look at this diagram on the right here, we see that there's protons in the nucleus, and I indicated them with red, and there's blue electrons. They're zipping around on the outside. Now, the protons are inside and they're positive. The electrons are zipping around outside, they're negative. Those are our two players in this game, protons and electrons. We do not care about the neutrons. Neutrons are like duds, they have no charge. Remember, when we write neutrons, we can write it NO. No charge, they don't have anything to do with what we're talking about now. So ignore neutrons. You're only playing around with protons and electrons. And if you think about colors, and I purposely chose these, what color do you get when you have blue and red? When you combine blue and red, you get purple. And we've been, you may not have realized, but we've been looking at charge, and it's always been in purple to remind you to look at the blue and the red, the positive and the negative. Okay, so when you want to figure out the charge, you've got to compare protons and electrons, reds and blues, to figure out what you get in the purple box, what the charge is going to be. So if we look at this first example here, we've got 1, 2, 3, 4, 5, 6, 7 protons. So we're going to write 7 over here. And then the electrons, it looks like there's 7 up to this point, and then there's 3 more. 10. Now, when you decide if it's positive or negative overall, you have to look to see if the positives and the negatives are equal. Do they cancel out? And in this case, they don't. We have these 3 extra negative charges. When you compare 7 and 10, you see that there's 3 more negatives. So over here, we're going to check off this box. And we're going to write there are 3 more electrons and protons. If there was only 2 here, we'd put 2 more. If there was only 1 extra, we'd put 1 more. But right now we have 3 more. So we're going to use this line to help us think about what the charge is going to be. Now, the final thing is actually writing the charge. If you decide there's more than one positive or negative, there's an imbalance, then we're going to come up with a charge. What is there more of? The charge. There's more of these negative things. And how many more? That's our number. So you always ask 2 questions. What's there more of? That's your sign. And then how many more? This is your number. So you're always going to have 2 components. So now we have a -3. So this is nitrogen. Why is it nitrogen? Because there's 7 protons. Remember, 7 protons, if you look on the periodic table, there's your atomic number that equals protons. So we know it's nitrogen. Nitrogen's the only element that's got 7 up there. So we would write 7 with a -3. I'm sorry, not 7. We would write N with a -3 charge up there. So N with a -3. Some people write N with a 3 minus. You can do the same thing, whatever works best for you. As long as you end up having a sign and a number. All right, let's look at the next one. The next one, if we count everything up, there's 1, 2, 3, 4, there's 10 protons. And if you count all the electrons up, there's 10 electrons. So it looks to me like these are balanced. There's no extras. So that means there's no overall charge. So we're not going to use this line. We're not going to use this line. We're going to say over here, protons equals electrons, 10 of each. The net charge is 0. This is the only time you don't have to put a little positive or negative sign because it's just a 0. Now, there's 10 protons. So if we look at the atomic number, it's 10. So we write Ne, and then you can leave it blank or you could put a 0 here. That indicates that there's no overall charge. The next one, we're going to look at how many protons. It looks like there's 3. We're going to compare it to the electrons. There's only 2. We're going to say, is that even? No, so we can't use that line. What is there more of? It looks like that's where they're even. This is my extra. So there's one more proton than electron. One more proton. What charge is proton? Positive. How many more are there? One more. So you're going to write Li with a +1. Now, the next one, I don't give you a cute little picture. I don't give you a way to compare them like that. What I give you instead is an element name and how many electrons there are. Now, I give you the element name because I know you know that if you can look on the periodic table and find the element, like here's carbon's box, you can look at this atomic number and you know how many protons. I don't need to give you all these cute little positive red circles. You can just look at the periodic table and figure out how many protons. But I do need to give you some information about the electrons, and I'm telling you there's 6 electrons. So when you compare protons and electrons, you're going to realize, hey, they're the same. That means there's no imbalance. There's no overall charge. It's a 0. So you can write C, leave it alone, or you can write C, a little tiny 0 up there. Whatever is best for you. And finally, copper with 27 electrons. So you're going to look on the periodic table to find out how many protons. You don't need those little circles. You just look over here and you see that it's 29. And then I give you the information about the electrons. I tell you there's 27. So you compare those two. Remember, red and blue are going to give us our purple, our charge. So it looks to me like there's 2 more of these red positives. So we're going to go up here. There are 2 more protons and electrons. That gives us what our charge is. What is there more of? There's more of those positive things. How many more? 2 more. So you would write Cu plus